I'm Johnny T. I work here locally at NAP. I've been there for a number of years, love it. Currently, I'm on the engineering services team, which helps them implement some DevOps stuff. We recently moved to Kubernetes. We also have a strong Ruby team, an Elixir team, and a Go team. We're also hiring for a couple of those right now. So when I'm not doing DevOpsy stuff, I love writing and coding in Ruby. I've been using Ruby for quite a while, and I think most of you here, as we've already heard Brandon talk about, even Matt's talk about, one of the great things about Ruby is the community and just the people involved. I remember finding this really cool language that, man, it had some interesting concepts that took a little while to learn. And it was fun being able to find a local user group to go chat with people about, man, tell me about symbols and tell me about blocks and yielding. So I love Ruby, it's great. We have I don't see him here, but we've got it's a special occasion to have Matt's here. I don't see him here, but I'd love everyone to be able to say with me on the count of 3, a big thank you to Matt, because Ruby has, I think, affected all of our lives, significantly. I love it. So on 3, we're gonna all, I know some of I myself am shy, I'm not very outgoing, but I want Matt to know we're all grateful. So 1, what? That's fantastic. He'll be able to hear it later. So 1, 2, 3. Thank you, Matt. Fantastic. Thank you. All right. So my talk is on a better way to manage secrets. So first, let's chat about what are secrets. What are we going to be talking about? Today, we're going to be talking about kind of 2 types of secrets. One is kind of like a static secret, but it's kind of configuration. So these are like your database credentials, could be a billing API key, even like AWS credentials, things that we know, okay, like this is going to allow something to do something on our behalf. We need to protect it. Another type of secret that we'll be talking about is encryption. Specifically, encryption of data at rest. So once you get into security, like data in transit is treated differently from data at rest that you're persisting. So these are the 2 kind of main types of secrets we'll be talking about. There are many other types of secrets that we won't be talking about today, but we're going to kind of focus on these because I think these are going to be very common. I think pretty much everyone's used database credentials. Encryption is, you may or may not be using it now, but with GDPR and other things coming up, like you may be running into it soon. So the current way that we manage static secrets. So we know, again, it's sensitive config that we know needs to be encrypted and protected. Like we don't want everyone to have access to it, even though it is encrypted. There are many ways to do this. One that I've used in the past is if you're using Ansible. Ansible has a built-in tool called Ansible Vault that lets you encrypt a file, and so it's actually stored in the repository, but it's encrypted. There's also many other. There's Kubernetes secrets. I'm sure, like Chef and Puppet. Like there's numerous ways to do this. But so starting to think about these secrets, with any of them, do you know when they've been requested or viewed? And that's different solutions. You may be able to say, yep, we've got an Audit Log for that. Another thing, what's the process? What would you do if a malicious or even like an accidental or malicious actor has access to them? Like what are they going to be able to do if they've got it and then they're able to decrypt it? What could happen? So we'll talk about more about that. So let's move on to chatting about the current way that we manage stuff related to encryption. I think that most of us know, if we're going to be doing encryption, that we shouldn't be rolling our own encryptions. It is kind of a cool problem and it's fun to think about, but we shouldn't be writing our own encryption. I think most of us know hey, we're going to use a standard library. We're going to use something that someone else has implemented, this well-known algorithm. We'll use that. So, even if we are using good encryption, how are your encryption keys stored and managed and accessed? Have they ever been in a place, especially like if you're using public key encryption, so if it has your private key, ever been in a place that it could have been copied? Like, could someone have a copy of that key stored on their hard drive that they needed to decrypt a production database backup at some point? I mean, so have the keys ever been in a place that they could have been copied? And another is, can you audit this? Like, do you have a record of who has a copy? Another thing, so when you are encrypting, keys that you're using to encrypt have a crypto period. Like, do you know what the crypto period? Generally, it's going to be time-based as well as the amount of data that you actually use to encrypt. After a certain amount of time, you want to stop using that because you're going to have, like, you've got a big enough data set that can start to become an attack vector. So, encryption keys have a crypto period. Do you know what it is? Have you rotated them? And, I mean, how do you deal with key rotation? You're probably going to need to keep old keys around, but you need to get new keys to clients. So there's a big process, and there's quite a bit involved with just key management. Another thing is, so if someone had like an old copy of a database, would you be able to stop them from decrypting? So again, just some thoughts about current ways that people manage some encryption stuff. So today I'm going to actually be talking quite a bit about a tool called, so it's a tool from HashiCorp called Vault. From their website, so Vault is a system to manage secrets and protect sensitive data. So it's in use, so for sure here locally, so we use it at NAP. We've been using it for a while. I know MX uses it. Adobe there's press about them. I mean, we know Adobe uses it. There's a lot of big companies that use it. It's a great tool. It has a lot of advantages, but there's a lot to it. One thing, so HashiCorp Vault. So if you're running Vault, you run it as a separate service. This service can be accessed via a built-in web UI, just a command line interface, or most often, from an applications perspective, you're going to just be accessing it over an HTTP API. One thing about Vault is, if you're using Vault to manage your secrets, in order to use any of those secrets, Vault has to be running and unsealed, which we're going to talk a little bit about this later. But you have to have a running copy of Vault that people are very much aware of. You can't spin up a copy kind of off-grid and be able to start decrypting stuff. There's more to it. Another thing that if you start using Vault that you'll kind of get used to is there are a lot of things that are meant to be out-of-band processes, meaning your application shouldn't be doing this. There's a lot of processes that they feel a little strange at first, and I remember when I was getting used to it, wanted to automate some of these things because I'm like, man, why do I have to do these extra steps? But when you start to get into it, you realize, wow, there's really good reasons why there are out-of-band processes that are meant to be run by a different type of user. So, Vault is complex. It's a big system. There's a lot going on. Again, if you're using Vault, it becomes a critical part of your infrastructure. You will have a hard time operating stuff if it's not running. So you want to run it you want it to be highly available, and running an HA Vault cluster is some work. There's a bit to it. That we won't be going into in this talk. I've got a bunch of resources at the end that you can learn more about that. So again, we're not covering all the topics of Vault right now. one of the big things I want to get across today is how you can use it from the app's perspective and recognizing that there's a system out there to help you do a lot of this stuff. So for our example setup, we will be running a Vault server in dev mode, which is an easy way to play around with Vault. Everything's stored in memory. A lot of things are kind of simplified. We'll also be using the Vault Ruby gem. And when we're interacting with Vault in these examples, there's kind of two key pieces of information. Sorry, that's a little hard to see. So there's a Vault adder. So this is the Vault adder. So it's where can I talk to Vault? And anytime that you're talking to Vault, you always have to you have to supply a token, which is who you are, who you're coming in to do something. So we can assume that we're going to be, in these examples also, we'll be running on HTTP. By default, it runs on HTTPS, because anytime you're talking to Vault, it should be over HTTPS. But for these examples, running on just HTTP simplifies. We don't have to deal with certificates. So to start up the dev server, you can just run. So again, starting from the CLI, you can start the server in dev mode, and we can provide it the value of this initial token. And we can say, okay, we're going to get a root token. We want it to be named root. Also, for these examples, we'll be using there's a secret backend. The newer version actually maintains version history of your secrets. We're going to be using V1. It's a little bit simpler API to work with. So now let's look at how Vault can help us with our static secrets, so like our database credentials and like API keys. So this is kind of an operator command. This is something that your application wouldn't do. But so say, okay, someone has created a new database, set up a database account. They would come in and use this in the key value, they're going to put, so the path is secret sign up. So if we had like a sign up application, and then we're going to add the database username and the database password. Now, once that's been added, so we can, from Ruby, or really from any client, so again, we're going to set the address and the token, just require Vault. The Vault Ruby gem can be configured via these environment variables. If you need to, you can also, there's a config stanza that you can specify to set these as well as some other options. So we can just read the logical path of secret sign up, and then if we get a secret back, and if we look at that data, we can see our username and password. Now let's look real quick at how we can use Vault for encryption. So one thing, so Vault has multiple secret backends. So we're looking right now at there's a backend actually called secret, which is the key value store. And then Vault has a backend called transit, which is it's basically encryption as a service. And so from Vault's perspective, it's encrypting stuff but only in transit. Vault never stores any of this information. So to set up the transit backend, so an operator again would issue the Vault secrets enable transit. That enables the backend, so Vault is now aware that, hey, I can deal with encryption keys. Now, so say in our sign-up process, we were gathering a social security number, which is not a great place to do it in the sign-up process, but for these examples, it'll help us out. So now that we've enabled the transit backend, we want to create a key that's going to be used for encrypting social security numbers. So this is, again, the operator command that we're going to create the transit keys, so SSN key that then our application can use. Once that's been created, we can come back to, again, looking in Ruby, how we would use Vault to encrypt data. So one of the things, so we can see we're using the Vault gem again and base 64. So when you are passing data to Vault to encrypt, it expects all of that to come through base 64 encoded, which is, it allows Vault to, you can operate on binary files just as easily as text. So if we had our plain text there, which is a social that we've gathered, we would encode, base 64 encode it, and then we're going to write to the transit encrypt SSN path and give it our plain text. Again, Vault, so that will send a request off to Vault. It will encrypt the data, give us back a secret. Then if we look, and so we now have a ciphertext string that we can then store in our primary data store. This is the encrypted social there that we gave to Vault. Decryption is going to be very similar. We could have some ciphertext that we need to decrypt. And so I love, for the decryption especially, that, I mean, obviously you have to have Vault running for the encryption, but in order to decrypt, if you're using Vault for the encryption, in order to decrypt anything, again, you have to have a Vault instance you can act against. So with an active Vault, we can send it the ciphertext, and then we get we get a secret back, and the data has our plain text that then we can use. So the root token. In all these examples, we've been using the root token. It's great for examples, and it's easy. I mean, it's just like, man, if you're having permission problems on something, just to see if it's that, like you can run it as root, see if that gets rid of anything. So the root token is something we probably need to deal with. So the root token is extremely powerful and can be dangerous. A number of years ago, we went to, from NAV, went to a Vault training and heard the lead engineer on Vault at the time use an analogy, which I'll continue, which I love, is that you should treat the root token like a captured enemy ninja. So in a production Vault, like super secure environment, when you spin up a new Vault cluster, you don't want to leave the root token alone. It's going to get displayed. You should have multiple eyes on it to make sure no one copies it off, and make sure it's used just for it. So I guess the next thing, so you don't leave it alone, and you want to remove it once you've extracted the needed information from it. So again, the root token, again, in a production system, you want to use it to initialize Vault and get it set up to the point that you don't need the root token anymore, and then you can get rid of the root token. One of the reasons that the root token is a good thing to get rid of is it never expires, which we're going to get into some more examples a little bit later to see why that is a little bit more important. So in order to remove the root token, we need to kind of do two things. So we need to add authorization so that we can, and these are policies. So within Vault, we need to be able to say, okay, this type of user, or this has a policy, they can do these types of things. And then a second thing is we need to be able to add authentication so that when we start interacting with Vault, we need to be able to prove to Vault that I am some entity. So policies in Vault. So they define what a token can do. They're also path-based. So everything in Vault is based on a path. So we saw it like secret/signup, secret/transit. So we're going to first look at what we would do with like an app policy. So now say we've got this app running, and we want it to do the things that we want it to be able to access this stuff. So here's an example policy for this app. So we are saying, okay, for the sign up app policy, we want them to be able to read the secret sign up. We also want them to be able to create and update so that the transit encrypt SSN endpoint. So that again is encryption only. And then there's a separate path if you need to do decryption as well. So that's the policy, and then again, an operator would run the command to create the policy. So we're going to create it named sign up app. While we're at it, so we could create also a somewhat temporary policy, but so this could be an ops policy that is basically root privileges, but it's going to be tied to a token that doesn't live forever, and it should also be identified by, like, you know who it is that's running it. So with these policies in place, we're going to go back to see how we would access this from, or how we'd use this in Ruby. So the token here, we're actually running a subshell to create a token that has a policy associated with it. Normally, you would do this preferably before your application even launches, but we're going to be talking about authorization in just a little bit. For now, know that we're able to create a token that's associated with this app policy. And then we can see that we interact with Vault, and we can get the database credentials just like we wanted. Another thing with Vault, it comes with a root policy and a default policy. The default policy is just basic information. Tokens can look up information about themselves, see when they expire. So in this example, we can see, if we create a token that's only associated with the default policy and try to do the same thing, when we try to access that data or that secret, we get an error back of Vault saying that the permission is denied. So we don't have permission to access that path. One of the things also, just quick note, in working with Vault, your most common things are going to be this permission denied. Like which is, and you gotta, you'll learn how to work through them, but that's, because talking to Vault's pretty easy. Getting a token can be pretty, but like it's usually policy, or yeah, Vault's just saying, hey, I see your request, but you can't do it. Okay, so those are policies. That's how we can say what a token is able to do. Next is authentication. So we want to allow different entities and different types of entities to authenticate to Vault. So for this, Vault has multiple authentication methods that you can enable. The one that is enabled by default is token. So if you provide it a token, it says it authenticates with that token, and you can continue. That's how the root token works. Another type of entity that is going to be interacting with Vault are people. So the operators are people that are managing Vault, but also putting in initial secrets. For this, Vault has a number of authentication plugins. So LDAP, you can use GitHub, your GitHub organization and groups within that. So even just basic username, password, Okta has a number of other ones as well. Another type of entity that needs to authenticate with Vault are machines. So your services that are running. For this, again, Vault has authentication methods for AWS, Kubernetes, Google Cloud, and also a number of others. But so different authentication methods for different types of entities. One thing is, again, so talking about some of these kind of out-of-band processes, it's a nice thing. So your application can interact with Vault completely on its own. So it could authenticate. We're going to get into leases in a little bit, but it's a good practice to be able to authenticate to Vault outside of your application, so that you can just provide your application a token, and then it helps keep your application a little bit dumber about this stuff. It doesn't need to know how am I going to authenticate. It's just going to expect that, hey, I need to have a token so I can work with Vault. So now that we've got these policies in place, let's go back and look at our encryption example. If we were running this now, we had an app up and going that was so gathering people's socials as part of the sign-up process, encrypting them. We would notice that after a while, we would start getting a permission denied. So we'd be up and running, can use Vault to encrypt, but then we'd start getting a permission denied. This is because our token has been revoked. So in Vault, another big concept are leases. So almost everything is tied to a lease and will expire at some point. So the root token is one big exception. The root token never expires. Pretty much everything else expires at some point. So one way, all right, one way to think about leases is a kitchen timer on a conveyor belt. So a lease has kind of two properties associated with it. there's a max time to live. And this is kind of like your conveyor belt. This is predefined, so the default is 32 days. So a token hack could be valid for up to 32 days. And then the timer itself is like the time to live. The default, I think, is 1 hour. So when you get a token from Vault, it can be good for up to 32, but it's set to an hour. And so after an hour, if you don't do anything, Vault's going to say, okay, you're done. So that the timer, so at that point, the timer goes off, the bell rings, and Vault revokes your lease. Within that hour, all of these tokens, you are able to renew a lease. So you can tell Vault that, hey, I'm still interested in using this, at which point Vault will, if you're within those 32 days, Vault will renew your token, and then you can see how much time you've got left. So as long as you continue doing that, you can use that token for up to 32 days. Again, all of these times can be configured to be whatever you need per endpoint. So again, their tokens are revoked either at the end of the max TTL or at the shorter, like 1 hour. So because of this, if we're using Vault for, especially like encryption, we need to renew our lease. If you're only using Vault for your initial configuration, then leases don't really matter because you get your configuration, you apply it, and you're done. You don't need to talk to Vault again. But if you're using it to do encryption, we need something to renew our lease so that we can continue using it. One example of how to do this is there's a tool called Console, which was initially built to use console as configuration management, but you can use it to just interact with Vault. Again, this happens outside of your process. What it does, you can provide it configuration, and it essentially will talk to Vault, pull in secrets, set them as environment variables, and then launch your application as a sub-process. It also then spins up so it's a Go routine, but basically a thread that's going to continue to just renew the token that it was provided. Another possibility is you could have, if you were using Console, you could do this within your application. You could do it as part of like a health check, something that's going to be routinely called. You could add in some logic to say, okay, at this point, like if our lease is below, like if your lease is below half of the allotted time, you can talk back to Vault and renew the token. So when you're using leases, you need something to renew them. You can do it inside of your process. You can wrap your process. You can run it as a separate, like a sidecar container in Kubernetes. There's lots of ways you could do it. So another thing that Vault can help us manage is what it calls dynamic secrets. So if we revisit our database credentials, now that we have, and we know that Vault has this concept of a lease, and that it will actually revoke stuff when it knows is no longer needed, wouldn't it be cool to have our database credentials in a similar spot? So we don't just create an account, use the password, have it be fairly long-lived, possibly not looked at super often. But so could we use a lease for these credentials? So the answer is yes, we can. So Vault has a number of additional secret backends. So it has a database backend that within it has a MySQL, Postgres, I can't remember, like a number of different vendors. But so you can set up and again configure Vault. I'm not going to go through the examples here, but you can configure Vault so that when your application says, okay, I'm ready and I need my database credentials, so you're already issuing a request to Vault, this would be now at a different path. And Vault, after being configured, would see, okay, this application needs database credentials. It would then create an account for that application that has a time limit on it and send those credentials back to your application. Again, you get a lease associated with that you will, again, have to renew. But Vault is going to be watching it, so as soon as that lease is revoked, Vault will then contact the database and revoke the database account as well. Another cool backend is AWS. So you can do the same type of thing, but for AWS credentials. So if you need access to an S3 bucket, you can, at boot time when you are starting up, you can say, hey, I need AWS credentials, and rather than just returning something that's stored within Vault and kind of hard code with like a static secret, Vault can be configured to be able to, okay, this app needs access to this bucket, so it'll create it'll create the necessary things in either AWS, there's also a Google Cloud, returning back the credentials, and then again associated with the lease so that it will be revoked once it's done. All right, another thing with, once you start getting into compliance and differing levels of compliance, so, and not even compliance, just good security. So audit logs are a good thing. Like they can be used for numerous activities, but you can use it for trying to look at what's going on currently and alert on stuff. But it can also be really helpful if something happened, you discover that, hey, you know what, 3 months ago something weird happened. If you've got audit logs, good audit logs, they can be really helpful in figuring out exactly what happened. All of the actions taken against Vault can be logged to a file. Again, an operator can run some commands to set up these audit logs. One thing about audit logs and Vault is once you've enabled the audit log, Vault will, any operation that comes into Vault has to successfully write to at least one audit backend in order for Vault to continue. Which means, so if you turned on audit logs and only set up the file backend and let it running on a server that you were never monitoring the disk space, at some point that disk is going to fill up, and then Vault will at that point freeze, and anything that's trying to use Vault will just be on hold. There are a number of different audit log backends that you can turn on, and you can turn on multiple. As long as Vault can successfully write to one of them, again, it can continue. So, other, I think, cool Vault stuff. So at NAV, we've been, we deal with social security numbers, dates of birth. We deal with business owners' credit information. So there's a lot of compliance. We have been using Vault for a little while, and it is really cool to see. So specifically with PCI DSS, which is, so one of the bureaus we work with used basically a clone of this. This is a standard that you use for financial process. Like if you were storing credit card numbers, you'd be using PCI DSS. So most of Section 3 in that compliance, you can just check off if you're using Vault, which is pretty nuts. There's a lot of questions about largely your key management. How do you deal with encryption, and how do you deal with the keys that you're using to encrypt? So compliance audits can be much more straightforward. Sections of them, Vault can help enable a lot of that. So Vault has a number of different storage backends. So again, all of these examples, you're just using the dev server that's running in memory. Once you're running an actual Vault server, you can store your data in etcd, console, Postgres, MySQL. There's a lot of different backends, different places that you can store your data. Another fun thing about Vault is, so it uses something called Shamir's secret sharing, which is, so Shamir he's the S in RSA. So he knows a thing or two about encryption. This is a cool way so within Vault, again, once you're running an actual Vault server, any data that Vault writes out to persistence is encrypted. And that is encrypted using a master or a key encryption key, which that key is actually never stored anywhere. Vault default, so when it spins up, you'll get 5 different key shares that you need to provide any 3 of those, and it will reconstruct that key that then Vault can continue running and actually be able to decrypt all of the the information that's stored in the storage backend. Also, so sealing and unsealing Vault. Again, so that's where the Samir's secret sharing comes into play. When you spin up a new Vault process, it will boot, but will be unsealed. Or sorry, it will boot, but will be sealed. And so you can access and get status about it, but it is actually at that point physically unable to do anything because it can't decrypt all of the information that's in the persisted backend. So once you launch the new process, you have to have, again, your configured number of key shareholders come together and unseal Vault, at which point they can actually start processing requests. Again, also if you're using a system, if you're using Vault, again, I've mentioned it becomes a critical part of your infrastructure. You will have a hard time operating significant things if Vault is not running or having problems. Because of this, it's good practice to be running Vault in so high availability mode, which allows, so if a node has problems, another node can be already unsealed and on standby that it can pick up and start taking over at any point. So, secret management. There's more to it than just encryption. Encryption is a big part of it, using the right keys, but there is a lot more than just encryption. So the key management aspect of it is there's a lot of process surrounding it. I want people to know that there are systems out there to help you do this better. Vault is one of them. There's a number of, there's KeyWiz is another great product. If you're just doing encryption, different cloud providers have key management solutions that can help you with just the encryption portion. But again, there's even more to security than just encryption and key management. So Vault can help you quite a bit with all of this. So I hope everyone knows a little bit more about security, knows a little bit more about ways that they could improve the way that they're dealing with secrets. Thanks. Great. So we got a couple minutes for questions if everyone has. So the question was, in one of the earlier slides, I talked about, so what do you do with an old database that, like, how do you deal with something that someone has and is going to decrypt? So the way that Vault can help with that is if you're using Vault to do your encryption, but you're actually storing the ciphertext in your database, if someone got a hold of that database, in order to decrypt it, they would have to actually authenticate with an active Vault node and send all of the data to Vault to decrypt it. They can't do it offline. They would have to, and so spinning up an active Vault and unsealing it is also something that a single person is not going to be able to do. So that's how Vault can help with that scenario. I would love to chat with Vault with anyone at any point, totally. So the question is, are there any existing Vault integrations with like CI systems? Probably, I'm not aware of any, but there's a lot of tools around Vault. So I'm not sure on that. I'd have to look it up. Okay, so again, come grab me anytime. I would love to chat more about Vault or Smalltalk or Ruby or anything. So thanks.